Hello everyone. I hope you all are well and safe. So far, we have been discussing about Telco Softwarization and we specifically looked at SDX and SDA. Today we are going to start a new topic which is Network Functions Virtualization. But before getting into Network Functions Virtualization, let's first look at what is a network function and what is the rationale behind virtualizing a network function. What is a network function? We have two words here. One is network, the other one is function. A network is a network like a LAN, local area network, WAN, a wide area network, or wireless network, or maybe a network of networks like the internet. But if you look for a more formal definition for a network function, it could be defined as a functional building block within a network infrastructure which has a well-defined external interface or interfaces and a well-defined functional behavior. But traditionally, if you look at all these network functions in a network, they are implemented as a physical appliance or a box or a hardware. For example, if you take a firewall is a network function. It performs the firewalling function, but firewall is a box or a hardware or a physical appliance in the network infrastructure. Same for a DPI or a deep packet inspector, that is also performing a specific functions which is inspecting packets, and it is implemented in a network as a physical device or a physical appliance. And we can go on discovering these devices, for example, network address translation device or a NAT device, and then a load balancer to load balance traffic, and then a customer premises equipment or a CPE, and then if you take a telecom infrastructure, you have broadband remote access servers or broadband network gateways, and then in a 4G network we have evolved packet cores, and also in a voice network or a multimedia network we have IP multimedia subsystem or IMS. So all these things are specific network functions and they define a very specific functional behavior. But today, traditionally, all these functional behaviors are implemented inside a physical appliance or a physical box. Now, what is the problem with this? What is the problem of implementing a box for each network function? One problem is the proliferation of proprietary hardware appliances, because these boxes, these appliances come from different vendors and they are mostly proprietary hardware. And then this increases CapEx or capital expenditure, OpEx, operational expenditure, and also it consumes space and power, because for each network function we have to have space for that particular box and it consumes electrical power, and that also includes capital and operational expenditures. One other thing is that it blocks innovation, because from the telco side you cannot do any innovation, because when you ask for a network function, it actually comes as a box for that particular network function. And also it prevents the rollout of new revenue generating network services. If you want to have a new network service, you have to actually wait till your supplier or vendor supplies you the box for that particular task, and that actually prevents you rolling out new services faster to the network and also to generate new revenues. Now, if you think openly about network functions and the way that we have been traditionally deploying network functions in networks, we have this question of, does it have to be a dedicated box? Why it has to be a dedicated box all the time? So if you really look at the rationale behind a dedicated box, And if you go a little bit deeper and think what is actually happening inside this box. Now, most of the time you understand that it is something related to a logic. If it is a firewall, you block certain IPs, or you block certain applications, or you allow certain applications, it's a logic. And if you do load balancing, it's again a logic based on something, you take some decision. Network address translation, or if you take any other device, any other network function, it's an implementation of a logic. So if it is an implementation of a logic, you can easily implement that logic through an algorithm. You can write an algorithm to implement or structure that logic. So if it is an algorithm, then you can write a computer program to run that algorithm, or rather to execute that algorithm. You can run a computer program using a specific computer programming language. So if it is a computer program, then you have to run that computer program inside a computer. So that is what we usually do, or a computing engine. So this is the reality. So you really need, or rather what you really need, is a computer to run that computer program, which actually about a certain algorithm, and that algorithm is actually an implementation of a certain logic for that particular network function. So you can really implement your network function inside a computer. So this is the rationale behind virtualizing network functions, because virtualization actually first started from the IT or the computing industry, virtualization of computers, and similarly you can now understand a network function can be easily virtualized because it is something, it's actually a program that is running inside a computer. So the only problem we would have is how much is my input output capacities. Can this computer perform the same input output capacities like a dedicated device does? Mostly these capabilities available in today's computers. So if you really take previously from day 1 or day 0, we just had network functions or just functions. And all of a sudden, we realized that some of the functions can be virtualized, and we call them as virtual network functions. The same network function, without using a dedicated hardware, you run inside a computing infrastructure. So you get this term called virtual network function. And going forward, we realize that most of the network function can be made virtual, and so you have multiple virtual network functions. The moment you talk about virtual network functions, then only we realize that there is something called physical network functions. We never call those hardware boxes as physical network functions, but the moment that we realize that we can virtualize network functions, we used to call the hardware implementations of network functions as physical network functions. Going forward, you can further take this forward, meaning that we can have cloud network functions. Now we all talk about clouds and microservices and things like containers, etc. So you can further make virtual network functions cloud network functions. So in a way, cloud network functions and virtual network functions are all virtual network functions, but cloud network functions are more towards the cloud native type of implementation of network functions. So we have 3 layers now: physical network functions, virtual network functions, and cloud network functions. And in the future, you may have other network functions as well. But the only difference is physical network functions rely on a physical dedicated device for that particular network functions to be performed. But virtual cloud network functions can be run inside a generic computer or computing environment. I hope now it is clear to you what is a network function and what is the rationale behind virtualizing a network function. We hope to discuss many aspects of network functions virtualization in our future videos. Bye for now.